Eco Guards, Innovative Eco Solutions. The premise of this series of videos is to properly articulate the nature of the electric battery-powered vehicle fires that are transpiring, and to properly educate anyone in the simplest of terms that desires to know the truth concerning how these types of battery fires are being created within the lithium-ion battery cell structures, as well as eventually showing our self-contained SNUFFERS units. In order to truly assist the firefighting communities throughout the world, how these types of fires need to be properly dealt with, while also assisting in protecting our firefighters, the public, and our ecological systems. SNUFFERS Units. SNUFFERS is an acronym which stands for Suppression, Neutralization, Ultimate, Filtering, Fire, Extinguishing, Removal Systems. In this last of our video series, we'll describe what is needed for an electric vehicle battery pack to catch fire, although many firefighters know these facts, and if not, then it's time to learn. In other words, all fires require fuel, heat, and oxygen in order to burn. We will also explain to EV automakers what we believe is the proper future EV fireproofing and battery fire suppression system that should be incorporated within all electric vehicles, which, if incorporated within all electric vehicles, would help our firefighters prevent future excessive fires within these EV battery packs, while also explaining how they could further develop and introduce fully equipped EVs with internal CO2 battery fire suppression systems, as they also keep safety and their cost of doing so in mind, while further explaining and showing our firefighters SNUFFERS units, which we believe will most likely still be needed. For there are many circumstances and scenarios that an electric vehicle could catch fire, well beyond the abilities of these fire suppression adaptations of the battery pack. We would also like to state that the majority of the video clips used in this digital eco-educational production are the property of their respected owners, and are only used here in order to express the true educational priorities that will be needed by all in order to properly deal with future electric battery-powered vehicle fires. The remaining contents and industrial designs are copyright, trademark, and trade names of Jemco Incorporated 1990 and Eco Guards IES, and should not be used without written permission unless for educational purposes only. Anyways, here are the first two real EV fire SNUFFERS solutions, followed by our third. Proper future EV fireproofing. It's time EV automakers help prevent these types of EV battery fires by engineering their vehicles with two emergency CO2 injection ports on the opposite side of the vehicle as the charging port. These two emergency ports would be designed to connect several CO2 pressurized canisters to be connected by our firefighters in the event they are required, which would allow for our fire departments to inject pressurized CO2 directly into the EV battery pack, thereby helping in suppressing the oxygen levels and helping in containing the thermal runaway process, but also preventing the hydrogen from mixing with air, creating Brown's gas. For it is believed that these lithium battery fires are comprised mainly of the elements needed to create such, being hydrogen and oxygen. Therefore, it should also be noted by our firefighters that you're not only fighting a lithium fire, but a Brown's gas fire. Fueled by the hydrogen from the lithium and the electrolytes that are heating and burning, and that adding water to this scenario creates further greater amounts of hydrogen fuel, which later become mixed with oxygen, making these fires even more intense. For it's also believed by us that when any water is introduced into these compromised batteries, that they take on the characteristics of a tubular HHO cell. Mostly because of their design with a positive and negative structure, as well as the energy stored in these batteries, but also because of the hydrogen that's already being created. Nevertheless, if achieved correctly, this re-engineered battery housing CO2 port injection extensions could be added to an existing electric battery-powered vehicle and would truly assist firefighters in containing these accidental types of fires before the EVs are fully engulfed, while also taking into consideration public safety and environmental concerns. Now also comprehend there will be some people that will not like the fact of using CO2 in order to extinguish these types of fires. Nonetheless, the toxic smoke given off by these burning batteries are very much worse for people and the environment than any amount of that element. For those battery fires have finally been seen by many as a hazardous material situation. For it's a well-known fact that CO2 helps contain fire, for it does not burn and also suppresses the hydrogen from mixing with air, at least in a contained vessel, which a battery pack is. Moreover, it would be possible to add a CO2 fire suppression system into an electric battery-powered vehicle, for when a proper computerized system senses any great volumes of hydrogen or heat within the EV battery pack, that's when it would automatically inject into the battery pack housing, while warning the driver of such. The engineering involved in creating this CO2 fire suppression system is not as complex as one would think, and we're sure the automakers could figure it out, for we have. In the event that an electric vehicle is fully engulfed, that's where our SNUFFERS units come into play. For these SNUFFERS units have been designed to completely extinguish these types of fires without water, while quickly helping our firefighters in removing these compromised vehicles from any accident site or parking lot. Once moved away and taken to a secure site, these units would no longer need to be monitored, thereby allowing our firefighters to attend other calls. Let's now explore why we designed our SNUFFERS units in this manner. The Eco Guards IES SNUFFERS units were originally conceived in November of 2017 in order to be used to help eliminate life-threatening situations that the public and our firefighters potentially face, plus the overall damages to public and private property, personal and ecological damages that may occur during an explosive situation as it relates to electric battery-powered vehicle fires. However, after years of on and off attempts to gain the assistance of several Canadian government agencies, and after being constantly refused, we have decided to show our SNUFFERS designs to anyone that may choose to assist us or take on this project on their own, as long as proper credit be given for our works and efforts. We are doing this in order to educate, protect, and assist our firefighting communities, the public, as well as our environment. Anyways, let's now explore the reasons why we created our uniquely different designs, and the many reasons why these SNUFFERS units are important. In the event that an electric vehicle's battery becomes exposed or compromised to the many conditions that may arise from sources such as failure of protective circuitry resulting in overcharging due to potential power charging station failures, or power fluctuations and sparkings of the main grid, to motor vehicle accidents that involve electric vehicles that may completely or partially compromise the battery housing units, and so on, which may cause those batteries to create a thermal-chemical runaway scenario that should not be controlled by dousing any unit with water. That said, the considerations of the extent of the penetration limitations of current dry powdered graphite or chemical-based fire extinguishing systems have also been explored and found to be lacking, for these cannot be forcefully injected into these compromised battery housing units without creating further penetration points. Until EV automakers address these future battery fire proofing facts on their own by possibly incorporating battery housing CO2 injection ports within their vehicle's overall structure, or fully equipping their EVs with internal CO2 battery fire suppression systems, a better course of actions, and as cost-effectively as possible, with greater safety and overall environmental concerns being at the center of the matters, will be to have any compromised electric vehicles placed into our uniquely designed reusable systems. That will then allow for the removal of said electric vehicle that's compromised with their failing burning batteries from any public areas, while also protecting the public and firefighters. Moreover, it should not be assumed that after any electric vehicle accident that these electric vehicle battery packs are stable. It is a well-known fact that all fires require oxygen, fuel, and heat in order to continue burning, even more so for lithium battery fires. And since our firefighters can't prevent the fuel or heat in the case of thermal runaway, there's only one that can be controlled: oxygen. Moreover, lithium batteries are very susceptible to runaway thermal-chemical reactions when water and great heat is introduced into the equation. Our device will eliminate those elements from that equation, thereby reducing the extent that any thermal runaway battery fire may continue. As is evident by the many censored and uncensored videos finding their ways onto the intranet, as well as all the documented news broadcasts of such events, electric vehicle battery fires are very difficult, if not currently impossible to control in a real-world scenario, as well as keeping people away from due to their sparking, explosive, attractive nature when these events transpire. Therefore, a quicker, better, reusable, more cost-effective, and safer manner of dealing with these types of events needs to be shown and adopted by all local, municipal firefighting departments. Moreover, true education concerning these types of mobile rechargeable batteries and the best manner of containing any lithium battery or Brown's gas fire brought on by whatever real-world scenarios may transpire are also truly needed. As was observed by recent conditions that occurred in many areas of the United States and elsewhere after major flooding events, these types of electric battery vehicles and their lithium battery packs are also susceptible to water, not just salt water. After observing that a flooded vehicle seems to spontaneously catch fire, but really they are susceptible to water in general, and they don't spontaneously catch fire. It's a reactive combination of lithium and water, for the water infiltrates these batteries through their pressure release valves or vents found within their structures. That said, salt water achieves a reaction faster than fresh water. Now you may ask, why do these lithium batteries have vents? The answer is to allow any gases to escape from their structures. That's created by the heat generated by their recharging. Moreover, these hydrogen-based gases need to be vented in order to not pose a further problem. Although these gases in general are limited in nature during these rechargings, but can increase with greater heat, such as those given off by our roadways and parking lots. You may also wonder why salt water reacts faster with these batteries than fresh water. We believe that these batteries' coils and layered-like structures are acting very similar to a tubular type or plate-like HHO cell. For those types of HHO cells require salt water and direct current electricity in order to create hydrogen and oxygen, in other words, Brown's gas. Although these batteries have not been designed to achieve such, it's very similar, and those similarities are being overlooked by scientists, battery engineers, and automakers throughout the world. That said, it usually takes someone to think outside the box in order to see such things. Moreover, sometimes it also takes inside-the-box thinking as well. You'll understand that reasoning soon. Now it's time for you to truly understand why SNUFFERS is an acronym which stands for Suppression, Neutralization, Ultimate, Filtering, Fire Extinguishing Removal Systems. The Eco Guards IES SNUFFERS units have been designed in this manner in order to assist in containing the compromised electric vehicles and its burning battery pack, while primarily taking away the oxygen that the fire requires, thereby assisting in also reducing the major heat source. They have also been designed to help reduce environmental and human exposure to the chemically based toxic smoke and gases that are generated by the burning of these batteries' electrolytes, anodes, and cathodes, as well as the added pollutants that may occur to surrounding areas and our water sources when other fire suppression means of snuffing these types of fires use vast amounts of water that are then contaminated and expelled into our ecosystems, let alone the extent of toxic smoke, carbon monoxide, and other vapors that further will contribute to climate change and health-related concerns. Therefore, the quicker these types of fires are contained and neutralized, the less overall damages. Although these snuffer units resemble cargo sea containers, their dimensions are very different, for they are 7 feet tall, 13 feet wide, and 26 feet in length. Those dimensions allow for the proper equipment to be placed within its overall structural walls, as well as allowing for a great many types of EVs to be placed inside, including such larger vehicles as Ford F-150 electric vehicles. Its height was also determined to be the most optimal, in order to have the ability to be brought into a multi-stage parking lot. Although it appears that there are 3 renditions in this video, the fact is that there is really only one. The version shown are just added in order to articulate the several ways in which these units can be used. For instance, the center version has been placed on a heavy-duty, low-platform trailer with solid rubber tires, and that allows for the containment and removal of said burning EVs from those multi-level parking structures. That said, there's a process to achieve this quickly, We'll delve into that soon. As is evident by observations concerning the manner in which some fire departments are currently attempting at dealing with these runaway, chemically heated reactive processes. When any damaged burning electric battery vehicle are further exposed to water, that reactive process, in conjunction with the electrical charge stored in these batteries, with their lithium, breaks the covalent bonds of the H2O, thereby giving these burning batteries further fuel, one of which is oxygen, in order to continue burning, even more so with salt water. Although that process is limited in a submerged water tank because of the lack of easily accessible air. Nonetheless, not completely eliminated, for the oxygen created and enclosed within the battery housing perpetuates further burning, and the water that's introduced continues to react with the lithium, thereby further impeding the ability of the firefighters to snuff out these chemically reactive processes. In the event that any fire departments are able to eventually slightly contain these processes with any water-based solutions, the facts remain that it's only temporary, for there is observed evidence that the thermal runaway process can rekindle once these vehicles are removed from any pools of water they've been placed in or allowed to stand with any water they've been doused with. Therefore, the reactive processes continue. Furthermore, when these charged lithium batteries burn, they may also produce greater amounts of hydrogen and oxygen, thereby creating Brown's gas. That said, Brown's gas is even more flammable than just either of these gases on their own, and is able to melt those other lithium batteries within the overall pack much faster. In fact, they've been known to explode. Now, those facts cause our fire departments to take up valuable time just attempting at fighting one of these fires for very many hours, if not days, for the firefighters' resources may be needed elsewhere. That indicated, our SNUFFERS units will further reduce the need for our firefighters to work towards containing these types of fires and further reduce the overall cost incurred by municipalities. That said, it appears that all parties involved, from governing bodies to the very institutes that are exploring a better means of controlling these types of fires, want a simplistic, quick fix and a manner in which to inexpensively deal with these EV battery fires. And to be blunt, it's not going to happen. Moreover, several more recent developments in the form of presumed battery fire extinguishing devices have shown a dangerous assumption based on their limited facts and limited extent of damages, or extent of forceful pressurized flames, and they are concerning for firefighters' safety, as is evident by the manner in which their devices are to be placed under the burning or compromised vehicle battery packs, while further penetrating and injecting vast amounts of water into any battery housing unit, thereby making these situations worse. That said, everyone's safety is of the utmost importance, and no water should be used unless attempting to remove people from an electric battery-powered vehicle involved in a motor vehicle accident that may be on fire. That said, it's not the fault of our firefighters, for they are not given the right tools and education to contain or suppress these types of battery fires. Moreover, one of those battery fire control tools does show promise. However, that's also part of the process we created in 2017. It is also a well-known fact that governments around the world are pushing for more electric battery-powered vehicles in order to take the place of standard combustion vehicles, thereby reducing CO2 levels, which partially contribute to climate change. Therefore, fire departments around the world must quickly adapt in a manner in which they safely and adequately deal with compromised electric battery-powered vehicles, or any battery fires. That said, those methods and cost-saving measures should not be too stringent. Moreover, the very element that is sought to be reduced in order to prevent climate change just happens to be the very thing needed to quickly put out these types of fires. In other words, CO2. Talking about adapting, Eco Guards IES, a not-for-profit organization founded in the 1980s, has and is also conducting research into creating devices that would allow for a different type of adaptive mechanism for motor vehicles that do not require such large numbers of batteries. In fact, our research is leading us down the road of using combustion-type electric generators that use Brown's gas, a cleaner type of fuel if used properly, a type of fuel that will not create CO2 as a byproduct, only clean, usable, nitrogen-enriched water, while supplying enough energy in order to charge hundreds, if not thousands of batteries at any given time, all with seawater. However, the mechanism used will use an inert form of carbon in order to achieve those goals. Nonetheless, this has been taking a great deal of time due to the fact that we are not supported by anyone other than our multi-generational Eco Guards members. Nevertheless, these explorations and developments have also allowed us to gain some knowledge and has guided us into creating these future lithium Brown's gas fire suppression tools. Moreover, while others have continued to insist that these electric battery-powered vehicles are the only solution for reducing CO2 as it relates to motor vehicles and climate change, the fact remains the very elements that are blamed for climate change are also the same as those required to prevent those changes. Moreover, our research has taught us a better manner of dealing with these electric battery-powered vehicle fires, and even though we are showing you a limited form of these types of devices, there is the possibility that this process may be further introduced into future models of electric battery-powered vehicles. For when designed in a more compact manner and adapted within the structure of future electric battery packs, it's believed that these types of thermal runaway conditions may be altered or eliminated quickly. However, that may be more difficult with leaf blade batteries, for when one of these batteries creates a runaway reactive process, eliminating any air within the cell structure may be almost impossible, mostly because there's no separation between the reactive elements. At least with the current cylindrical battery types, it's more controllable. But we digress. Before we continue any further, we feel it's very important for you to view this 5-minute video clip.
This is a nickel and cobalt battery, popular in electric vehicles in the US and Europe. And this is a lithium iron phosphate battery, also known as an LFP battery, which is popular in China. It has a shorter range, but it's cheaper to make, less prone to fires, and lasts longer. Both of these batteries were made by CATL, a Chinese company that's the world's largest EV battery maker. Of the 10 biggest EV battery companies, 6 are Chinese. China is the dominant force in EV battery production, while the US is deeply reliant on foreign batteries. China assembles more than 2/3 of the world's electric vehicle battery cells. US automakers lag far behind. Several companies have outlined plans to build plants in the US, but shifting battery production is difficult. Panasonic, a Tesla partner, learned this when it started building a battery plant at Tesla's Gigafactory in Nevada. Panasonic found it couldn't just import equipment from Asia. Different safety regulations and different operating conditions made it a challenge. It also had to train workers to make batteries, a finicky process where small mistakes can have major consequences. After years of its joint battery business operating in the red, Tesla and Panasonic's cell production has become profitable, and it's now a model for other automakers to follow. Other companies have found getting EV battery factories up and running takes longer than they expect. The earlier parts of the supply chain that are more difficult. Before you can make finished battery cells, you need to build all the components that make it work: the anodes, cathodes, separators, and electrolytes. China is the global leader in producing these components. The US is far behind. The US government has invested billions in companies that are trying to do this domestically. But companies can need years to develop the technology and ramp up manufacturing. Automakers accustomed to slower development cycles are trying to revise battery development strategies in response to changing mineral prices and technology. For example, companies have two main choices when it comes to cathodes, the battery cell's most expensive component: nickel and cobalt, used widely in the US and Europe, or LFP, common in China. US companies have historically preferred nickel and cobalt batteries for their long range, but volatile mineral prices have led some automakers to turn to LFP batteries. While these batteries can't travel as far between charges, they typically last longer and have better thermal stability, meaning they're more resistant to heat. Some US automakers are particularly interested in them for entry-level vehicles. Before you can make components like cathodes and anodes, you need to process and separate the raw materials that make them up. The US currently does little of this, while China is the world leader. And companies often have trouble building chemical processing facilities in the US. And then there's the matter of getting the raw materials. Most of the minerals in electric vehicle batteries aren't mined in the US or China. They're imported from countries like Australia, Indonesia, and Congo. China has strong relationships with these countries where it can get raw materials. The US is building new mines domestically and also building international partnerships. But both approaches have challenges. Some companies, though, are focused on an alternative source of materials. Instead of mining new materials, they're salvaging minerals from scraps and dead batteries. Ascend Elements is a US startup focused on producing engineered EV battery materials. It currently operates a recycling facility in Georgia and is building a larger one in Kentucky that may cost up to $1.5 billion. The company says it can produce enough cathode precursor and active materials to equip 250,000 EVs per year. Recycling startups are among the more promising American battery materials suppliers, but they're far from matching the output of factories in China, the world's largest battery recycler. And they're years from contributing a meaningful amount of material to the market. Ascend Elements takes used batteries, discharges them, and shreds them to recover the critical components like lithium, nickel, and cobalt, while separating out materials like copper, aluminum, and plastic. They call the remaining powdery material black mass. Through this process, Ascend says it recycles up to 98% of the critical battery materials and does it with a significantly smaller carbon footprint than mining and traditional cathode manufacturing methods. It's currently focused on making nickel manganese cobalt cathode precursors and active materials. Recycling may not enable the US to outpace Chinese production, but it could still be an important part of its domestic supply chain.
Again, it can't be overly emphasized that smaller cylindrical batteries are far safer. Plus, when and if they thermally run away, there's at least a better chance of controlling that process. For leaf, pouch, and prismatic type batteries don't have clearly defined separations between the electrolytic compounds. Therefore, if these types of batteries thermally run away, it's more difficult to extinguish. That said, the extent of complexities involved in manufacturing of any batteries and the nature of the elements used is not being truly analyzed for altered properties in a great many scenarios. As we continue to explore our thoughts on these matters, as well as our SNUFFERS units, we want everyone to truly understand that what you will witness is not conveyed in its entirety, for these units can achieve many other things well beyond our current articulations. Moreover, there will be some people that will indicate that we should have used argon as the gas of preference to snuff these fires out, we would indicate this: argon is more expensive than CO2, and it is not as heavy an element, and in many occurrences no gases are introduced into these SNUFFERS units, unless they are used to dry flooded vehicles. For the only gases that are in these snuffer units are created by the burning batteries, as well as the filtering, cooling, and the conversion circulation system. And to be blunt, that's actually one of the most impressive features of our units. As is evident by the numbers of electric vehicles being sold and used in Asia, and the true numbers of EV fires transpiring worldwide, as more of these current types of electric battery-powered vehicles make their ways into our societies and communities, a greater need for public safety in the event of such battery fires is needed, and a cost-effective, safer manner of having our firefighters successfully combat these types of fires needs to be achieved. And that includes fires from other types of batteries and sources, such as electric bikes, mass energy storage units, etc. Now, with that indicated, it should also be noted that regardless of the battery's internal elements, such as lithium, sodium, phosphates, and cobalt, or other types of internal structures, that these snuffer units will help contain and control those violent reactive processes. Moreover, Eco Guards IES has also conceptually created a manner in which compromised electric bikes may be contained and removed from a site and placed into our SNUFFERS units in the form of large dual fiberglass wraps in order to effectively, safely, and completely wrap the compromised e-bike that may then be quickly carried by several firefighters and moved into our SNUFFERS units. In fact, it appears that these types of containment wraps, or high thread count fiberglass blankets, are now being used by some fire departments in order to help contain electric vehicle fires. We'll delve into that aspect later. Suffice to say, we've been promoting and advocating for these types of e-fire solutions since 2017. Although the true best solutions would to not allow e-bikes to be stored for recharging indoors, rest assured, as these e-bikes become more prevalent within our societies and more fires erupt due to the many circumstances brought on by these e-bike fires, municipal, provincial, state, and federal laws will be enacted, thereby making those legislations a reality, forbidding the recharging within residential, apartments, and complexes. In conjunction with these large dual high thread count fiberglass wraps, it may also be possible to create smaller SNUFFERS units in order to make them standard equipment during recharging these units that could be sold or made standard equipment with any e-bike sale. That said, the cost of doing so would be minimal in comparison to the property damages caused by these e-bike fires or the potential loss of life. We're sure many insurance companies would appreciate that. However, that would increase the cost of owning such an e-bike. Now, with that indicated, Eco Guards IES have innovatively created the conceptual designs for our reusable electric vehicle SNUFFERS units. Although we have decided to limitedly express those overall renditions within this video series in order to assist any municipalities, fire departments, and governments that wish to further protect our communities. That said, we have not had the opportunity to conduct real-life developments and proper testing of our prototypes, only the industrial CGI designs. Nevertheless, we will attempt those actions if the public, firefighters, businesses, or insurance companies desire that we do so, but only with their financial support. For our local, provincial, and federal governments don't seem to want to assist in creating innovative eco-solutions that they require for our firefighter departments. That said, they are more than happy to spend billions of taxpayer dollars helping in creating these types of dangerous lithium batteries, but not the solutions that could help our firefighters quickly contain and control those types of fires. That indicated, we'll create GoFundMe and GiveSendGo pages entitled Eco Guards IES that will be linked within our Facebook group page and Rumble and YouTube channels in order to ask for the public, businesses, insurance companies, and firefighters donations towards those goals. That said, those costs should truly be borne by the companies introducing these battery dangers into our communities, but we'll see if any show a desire to assist. Moreover, the cost for such prototype developments and any modifications, as well as extreme proper testing, could currently vary between $2.5 to $3 million USD, time dependent. That said, the eventual cost of full-scale manufacturing of our e-vehicle snuffers, after proper evaluative testing and the formation of the industry, has been approximated to be $74,000 per unit, to be further reduced once completely scaled and established, not including the fire department vehicle, which would be needed to move these reusable units around. That said, the estimated cost for the smaller e-bikes version would be determined at a later time. That indicated, in the event that the EV automakers decide to use our innovative eco-solutions as it relates to the CO2 battery injection fire suppression system, it would be great if they would fund our further prototype developments and extreme proper testing of our larger snuffer units. However, we'll see if these designs are used without compensations. The illustrations included shows multiple versions of the simplest forms of our device, but does not truly articulate how these snuffers are manufactured, or how any firefighters need to conduct those actions, for there are many real-life scenarios that are ever-changing, and not every motor vehicle accident or battery fire situation is the same. However, a great many have been thought of during our analysis and designing, including the fact that these types of fires continue even during the moving of the compromised e-vehicle. Now we will slightly explore and explain how these SNUFFERS units work, as well as how any firefighters will need to use these. The first thing that must take place after any electric motor vehicle accident, and only after the vehicle occupants are removed and during their health needs being addressed, is that a large, thick, fire-retardant, non-conductive, tightly woven, high thread count fiberglass blanket be draped over the compromised, burning vehicle. And then, with the assistance of two further tightly fastened sections of this type of fiberglass blanket, they are to be pulled beneath the bottom, but between the four wheel wells, in both directions, and around to the top of the electric vehicle, using long hook poles with looping fiberglass ropes. Once fastened off, the firefighters may proceed. Now, with that said, if the electric vehicle battery is only slightly smoldering, it may be possible, if achieved quickly, to skip the wrapping of the e-vehicle and proceed to using only the pulling net and having the e-vehicle brought into our SNUFFERS unit. However, for safety reasons, the firefighters may opt to use the blanket anyways. Again, it can't be overly stated that any e-vehicle involved in a motor vehicle accident should not be considered safe from any potential runaway chemical reactive fire. Even if the e-vehicle looks to be in somewhat good shape, it does not appear to have any compromised battery pack, it should still be placed inside one of our SNUFFERS units until truly determined to be safe. Moreover, these fiberglass wraps, when used, should be tied off at the very beginning in order to reduce the possibility that this blanket may snag while the compromised, smoldering, burning vehicle is pulled into our SNUFFERS unit, thereby reducing any potential sparking or extensive flames from injuring any bystanders or firefighters, for these types of battery fires are very forcefully ejecting flames and chemicals at tremendous velocities and distances, but not always. Again, many factors transpire with every type of accident. These actions also make it much safer for our firefighters to conduct their further actions needed, and helps reduce any further damages to the surrounding structures, vehicles, property, and ecology. Once this is quickly achieved, a fire retardant cabled harnessed pulling net is then placed at the rear of the burning vehicle, while our firefighters stand on each side at a relatively safe distance, holding the net and the connection points tighter. Although the pulling net looks rigid in this rendering, it is not. It's made of folded fiberglass with an inner metal cable structure, with connecting hooks. This is when the fire retardant extension cabling from the internal winch system is then brought by two other firefighters and connected to the cabled harness net. When this occurs, the cable's slackness is reduced until the cables are tight. That's when all firefighters step away. That's when a firefighter control operator, standing outside the rear of the SNUFFERS unit, then begins to guide and pull said burning vehicle into the SNUFFERS unit, with the use of a multi-pulley directional winch system, which is capable of truly guiding the burning vehicle with the firefighter operator's assistance, while watching said vehicle through a fireproof and pressure gradient window at the rear of the SNUFFERS unit, and aligning it as it makes its way up the ramp and then into the holding area. Once this is achieved, the two cargo doors are then sealed and the ramp system is hydraulically externally retracted behind the doors. Upon executing these desired actions, the firefighter control operator locks the winch system and engages the vacuum system, which extracts most of the air and some smoke from inside the tightly sealed unit. After approximately a minute, the vacuum system is shut off and sealed. As this takes place, any remaining air will be further used by the burning batteries, as well as our process, and this will also contribute to the creation and expelling of CO, CO2, and other gases into the chamber, thereby replacing any air within the SNUFFERS unit. That said, another process then begins to forcefully filter the smoke and circulates the other gases throughout the catalytic converters that are sealed within the internally circulated chambered unit, thereby reducing the levels of CO and increasing the CO2 levels, but also assisting in cooling the burning lithium batteries, for those are forcefully pushed beneath the electric battery-powered vehicle. These actions, as well as the continued burning of the batteries, will then eliminate all air, thereby effectively snuffing the burning vehicle's battery system. In other words, replacing any air in the SNUFFERS unit with only high concentrations of smoke, CO, and higher levels of CO2, and other non-igniting gases, but also assisting in cooling the battery pack, thereby helping in reducing the reactive thermal process. It cannot be overly addressed and stated that adding water to any scenario involving compromised lithium battery housings and high voltages be avoided, for this may cause a furthermore explosive condition. Please note the previous video examples of lithium being added to water and how it reacts. Although these SNUFFER units are substantial in size, even more so than a normal sea cargo container, They also allow for the proper containment, removal, and disposal of small, mid-size, and large pickup truck type burning vehicles to be safely transported to a fenced-in holding area outside of public zones, thereby allowing for the allotment of time that will be needed in order to facilitate the proper cooling and analysis of any potential rekindling of the battery fire. Take note of the different versions of our SNUFFERS units, for there is one that is placed on a very low platform trailer that has solid rubber tires. This is designed to enter and assist in the removal of any compromised EV from within a multi-stage parking structure, thereby helping our firefighters in containing but also removing these burning vehicles. Further reinforced precautions have also been placed within the overall structures of our SNUFFERS units, as well as very small one-way vents on top in the event that some water has been used during the initial occupant rescue or fire suppression phase, thereby allowing for the temporary release of any potential hydrogen buildup, primarily due to the fact that hydrogen is normally vented and produced within the lithium battery, as well as when they are heated and burned. Moreover, it's also produced by the electrical discharge and water covalent braking, and is very much lighter than air, and has a tendency to escape upwards through much smaller leaking areas. Later in time, after the SNUFFERS unit has been observed, and upon the validation of the complete exhaustion of the battery fire and thermal runaway process, and the complete protectively controlled venting of the chamber, the electric vehicle may be removed by dumping or pulling the vehicle from the SNUFFERS unit, thereby allowing for the SNUFFERS unit to be cleaned or repaired if needed and put back into service. Take note that these SNUFFERS units may also be used for drying out any flooded e-vehicles by injecting large amounts of CO2 from canisters into these units and having our units circulate the CO2 for very many weeks, while periodically or daily releasing the evaporated and condensed moisture out of the SNUFFERS units. In other words, our SNUFFERS units are equipped with not only circulation systems, but dehumidifying and cooling systems as well. The only difference from standard units is that they are enclosed within the overall systems and don't use any air. It is advised that this cleanup and removal of the burnt vehicle from the SNUFFERS unit transpires inside a well-equipped and vented metal warehouse, or large facility able to conduct those proper ventings and reclamations. Moreover, human protective safety gear will also be needed during this process. All these actions are imperative in order to reduce any potential water source coming into contact with the compromised battery housing. That said, it's of great necessity that everyone understands that the manner in which lithium-ion batteries are manufactured for e-vehicles requires pressure release valves or slight openings in order to allow for the venting of other gases that are created during recharging of the battery units. These areas allow for water to enter the cell structure during a flood or during attempted firefighting with water, and regardless of the types of battery's outer casing, whether cylindrical, pouch, or the leaf blade battery design, these vents are and will be present. Further, in the event that any municipality refuses to properly deal with these removals, a further industry may come into being, one that specializes in these reclamations. Nevertheless, once the battery fire is truly eliminated, the transfer of said vehicle to another cargo container for transport to these types of facilities would be required, unless our governments require those compromised vehicles to remain in our SNUFFERS units until properly dealt with. Depending on the size of any given municipality and the extent of electric vehicle battery fires. It's believed that a community of 250,000 people may require 4 to 6 of these units that may be transported when needed with the use of 1 or 2 fire department tow or equipment trucks. That said, these requirements are to be determined by municipal councils and fire chiefs, but also by the extent of electric, battery-powered vehicles within any given community. Although a different manner of moving these units around may be used if towing company employees are better and further trained to assist our fire departments. Now, with all that indicated, the true best course of action would be to not create these types of batteries. However, since EV companies and governments are adamant in having these produced, it's only right that a proper manner of dealing with these types of battery fires be created. It's with great optimism that we have conducted these creative research actions, but now it's time to create actual working models that may contribute an added tool set that all fire departments will require. Moreover, those prototype explorations and testings may also be conducted by others in the near future. With your possible future financial and enthusiastic support, we believe that we may contribute further to a brighter, safer, cleaner, and ecologically sound future for all.